Hi there, my name is Mark Pinjaitan. Today I will be presenting my project for my Intro to Cognitive Science class. It's an experiment that I carried out that was testing representational flexibility and educational backgrounds. So, as an introduction, one of the fundamental concepts in cognitive science that I learned about was understanding how sometimes the format of a problem and the representation that people create can affect the efficacy and cognition of a people. So a demonstration of this principle was found in the Wason selection task that I read about, where a logical problem that is nearly impossible for most participants in an abstract form can become easy when reframed in a different type of context, even though the underlying logical structure is identical. Um, and so also I wanted to I wanted to test this concept by comparing the representational flexibility of people by their educational background. And so, what's the practical implication of this? Well, first is like building off of Wayson's experiment and trying to see can this still be provable that different representational formats have different performances. And then secondly, the most practical implication is that recently in 2025, NPR released an article discussing how the cost of graduate education in the United States has been rising sharply in recent decades. So I wanted to understand if graduate training actually improves your cognitive power and if it's like supported by cognitive science theory. And so I designed an experiment to carry this out. My experiment had 72 participants. It was carried out by using an online within subjects survey, and I recruited most of them from my personal network. And so the independent variables was the educational background of the participants and the format of the section. I'll get into that later. And the dependent variable was the accuracy and time that people had on the different formats sections. And then I also leveraged the Likert scale from 1 to 5 to test people's ease, confidence, and switching comfort, with 5 being like the highest score and 1 being the lowest score. So for instance, like a confidence score of 5 means that participants felt very confident about solving the questions. And so I had 4 hypotheses. First was that master's students would perform better than bachelor's in terms of accuracy. The numeric format would be the easiest, maybe, just because a lot of the master's students that I knew I was going to recruit was probably going to be in the STEM field. The third hypothesis I had was that the mixed format would be more difficult in the pure format, and then finally, confidence would be positively correlated with performance, specifically based off of like master's and bachelor's. And then, so the way I carried out this test was I had 3 sections, right? So the first section was a visual section where people were given isomorphic questions. The second section was a numeric section where people were given the same visual question but just put in numeric form, right? So for instance, if the visual section had a bunch of dots, I would actually just put the number in there. And I kind of use like the Ravens matrices test I used earlier. So like if you had like a 3x3 grid and it went like 1, 2, 3, 4, 5, 6, 7, 8, 9 in dots, and then I would just make that same problem in numeric and do 1, 2, 3, 4, 5, 6, 7, 8, 9 with numbers, and then you'd have to figure out, hey, what would be like the next row or something like that. And then finally, I had a mixed format section where you kind of have to switch between both visual and numeric sections. And so each visual section and numeric section had a counterpart with each other, and then a mixed format section had a visual numeric question counterpart inside of it. And so the results are in the middle. As you can see, accuracy didn't really differ that much. The biggest thing is that time differed a lot, and that the numeric section took the longest for people. And then finally, confidence dropped a lot for the mixed section. So what does this mean? The first finding is that, hey, visual and numeric formats produce equivalent accuracy but different time costs, which means that representation formats can probably impact people's solving abilities. Secondly, the act of switching itself might be the actual problem rather than the format in isolation, because that's where we see people's confidence dropping the most and accuracy dropping the most. The third, we found that educational background didn't seem to predict accuracy, but seemed to more actually predict the ability for people to switch between formats. And then finally, ease and confidence ratings don't really differ based off performance. Based off of education. So yeah, thank you.